our session. That is the free workshop on GATE, how to secure AIR under 100 for GATE 2024. And that is the session taken by the highly experienced faculty member, that is Dheeraj Sardana sir. So you can register now for this workshop, that is on this Tuesday at 7:30 p.m. Please note the time and note the date, that is on 6th June. Okay. Then finally, now I am going to start my session. That is a first order RL circuit. What is the first order RL circuit? One circuit is what? Source free RL circuit. This is the source free RL circuit. Second circuit is what? With source, R and L. Okay. So this is the RL circuit and this is without source and with source. So normally we are having question on these two diagrams, but different types of questions. In previous class, already I have given you the idea about the circuits. What about the transient, how we are going to get the differential equation and how to solve the questions. Okay, now try to solve these questions, everyone. Then this is the first question. Find I and Vx. This is I, that is the nothing but the current through the 2 Henry inductor, and Vx, that is nothing but the voltage across this 4 ohm resistor in the circuit of figure. When it is asked I and Vx, means for t greater than 0. You have to find the equation, that complete equation for I and complete equation for Vx. Then let I0 is 5 ampere. This is the initial current. This is the initial current through the inductor. Okay. Then if the initial current is given, okay, try to solve this question. If the initial current is given and there is no source, this is a voltage controlled voltage source, but it is dependent source. No other active sources. Once the inductor will discharge, finally the energy across the inductor will become 0. What will be the current through this 4 ohm resistor will become 0. So when Vx will become 0, 2Vx will become 0. So ultimately at t equal to infinite, I will become 0 because there is no source. Vx will become 0. So what is the final value? 0. That we can say because there is no other active independent sources. Okay. Now what is the initial current? 5 ampere. If you have the initial current, then what is the equation? I final minus I initial minus I final minus I initial e raised to power minus t by tau. What is the final value? 0. 0. It will become I initial e raised to power minus t by tau. So it will become 5. This one. This is the equation. This is the current through the inductor. Once the current through the inductor is known, you can find the Vx, because this current will enter like this. This is enter through the minus, leave the plus. That's why the Vx will become minus of I into what? 4 ohm. That is minus 4 times IT. This is IT. You can write this equation and it will become what? Minus 20 times of e raised to power minus t by tau. Now simply you can get this equation. You have to find the time constant only. Time constant only. The final value is 0. Initial value we have the idea. Then how we can calculate the time constant for this circuit? This is given by L by RTH. L. What is the value of the L? 2 Henry. And at this point, you have to find the RTH. Means you have to remove the RL and find the Thevenin's resistance across these 2 points. That is AB. Right? So, Sujit, what you want? Simply try to understand. What is written here? Find the I and Vx in the circuit of the figure. That is the equation we have to find. Once there is no active sources. No active sources means no voltage source, no current source. It is a dependent source. It is an active source, but it is dependent source. No active independent sources is present in the circuit. So at t equal to infinite, what will happen? The inductor will completely discharge. So what is the voltage across the resistor? 0. What is the current through the inductor? It will be 0. This will act as what? Short circuit finally. So at t equal to infinite, I0, Vx0, and what is the initial current? 5. So in previous class already I have given you the equation. I is equal to infinite minus I0 e raised to power minus t by tau. Final value is 0. Initial value is given in the question. That's why directly you will get this equation. 5 e raised to power minus t by tau. What is the Vx? Current is moving in this direction from negative to positive. So according to the KVL, that will become negative value minus Vx. What is the Vx is equal to minus 4 times of I. What is the I? 5. 5 into 4, 20 raised to power minus t by tau. So you have the equation for I, you have the equation for Vx, but you have to find what? Tau, time constant. So for time constant, what we are doing? First of all, 2 Henry inductor, and then you have to find what? You have to find tau, means RTH. How we can find the RTH? First of all, remove the inductor. Then this diagram is like this. This is 4 ohm. Okay, and that is 1 ohm. And that is 4 ohm plus minus Vx. This is dependent sources given. Now remove. When we are removing the inductor, you have to connect a battery of what? 1 volt here. And let this is the current I. So what is the Thevenin's resistance for dependent sources? It will become 1 divided by I. So what is the rule? First of all, remove that part. I am removing the L inductor and we are getting the open circuit. Now find the Thevenin's resistance. That is nothing but RTH. RTH is apply the external battery 1 volt and let this is the current I. Then that will become I 1 by I. Now this is what 2Vx. So from this diagram it is clear the same current will flow, it will enter through the plus, leave the minus. So what is the Vx is equal to 4 times of I. If it is 4I, then 2Vx will become 8I. 2Vx will become 8I. Then how we can find the I or how we can find the 1 by I? That is a very simple question. Now you can apply the KCL or KVL or what mesh analysis, it's up to you. You can apply anything to find the value. Okay, just now how I can find the values? For example, let's try to understand how we can find the I. Then we can write the KVL, but what is the voltage division rule? We have no idea. What is the drop here? Now this Vx, what is the voltage at this point? Suppose I want to find the voltage at this point, like this is the VA. So VA will become minus Vx plus 1. That is one way. Minus Vx plus 1. This is minus Vx plus 1. This is the VA. Now, once the VA is known, apply the KCL at this point. What will be the KCL? VA minus 1 divided by 4 plus VA minus 2Vx divided by 1 plus VA divided by 4. VA minus 0 divided by 4 is equal to what? 0. That is the KCL. Now you can take 4 as a LCM. It will become VA minus 1 plus 4 times of VA minus 8 times of Vx plus VA is equal to what? 0. Now 4 will become 0. 4 plus 1 5 plus 1 6 VA. On next page 6 VA 4 minus 1 minus 8 Vx is equal to 0. 8 Vx is equal to 0. Now what is the VA? Minus Vx plus 1. Minus Vx plus 1 minus 1 minus 8 Vx is equal to 0. Minus 6 Vx plus 6 minus 1 minus 8 Vx is equal to 0. Now minus 8 plus 6 minus 14 Vx, check my calculation also, and plus 5. Now what is the Vx? Vx is 4 times of I. Vx is nothing but 4 times of I. You can put I plus 5 is equal to what? 0. Now this is 56 times of I plus 5 then you can find 56 times of I is equal to 5, right? So what is the 1 by I? 56 divided by 5. And what is the 1 by I? What is the 1 by I? RTH. So in this way we can find the RTH. So first of all, draw the diagram, right? Okay. You can check my calculation, it doesn't matter, but remember how we can find. First of all, remove the inductor. These are the 2 points. This is the current I. You can find the Vx is equal to 4I. This is I have written. Then what is the VA? This is when I am writing the KVL from this point to this point, it will become minus Vx plus 1. This is the minus Vx plus 1. That is the value of the VA. Write down the KCL at this point. When I am writing the KCL at this point, VA minus 1 divided by 4. VA minus 2Vx divided by 1. VA minus 0 divided by 4. Take the 4 as LCM and solve it. Once RTH is known, L is known, what is the time constant? L by RTH. Now what is the L? 2. RTH 56 by 5. It will become 10 divided by what? 56. So what is the equation here? What is the equation for the I? 5 times of e raised to power minus t by tau. It will become minus t by tau, 10 by 56. So we can write 56 divided by 10t, and that is nothing but 5.6t u. Okay, so this type of equation you will get. So if nothing is given, then you have to find the time constant of the circuit by using the Thevenin's equivalent circuit. So this is a very important question for you guys, and that is the question from standard textbook, Alexander and Sadiku. Practice it, important one. Check my calculation also, no problem. Now, and that is the method how to solve the question here. Okay, then next question. Now this type of question in competitive exams, that was the question from standard textbook. The switch in the circuit shown in the figure was open for long time and is closed at t equal to 0. And is closed at t equal to 0. This is the 10 ampere, this is the 5 ampere, and exactly at t equal to 0 it is 0. It will close. Current IT, you have to find this current. That is the current through the inductor. Current through the short circuit path. What is the current through the short circuit path here? Okay. So when we are saying that it is closed at t equal to 0, means what? It is open for long time. Written here open for long time. So when it is open for long time, then circuit will reach to what? Steady state. Circuit will reach to steady state. T equal to 0 negative, circuit is in steady state with inductor act as short circuit. So this inductor will act as short circuit. Under steady state, the switch is open. Make the switch open. Okay, that switch is open. Now, watch this diagram. This is the 10 ampere, 5 ampere. This will act as short circuit, and that's why this 10 ampere is divided into 5 and 5. So what is the current here? 10 divided by 2. Because this will act as short circuit. 10 divided by 2, current division rule. So what is the initial current through the inductor? 10 by 2, that is the 5 ampere. 5 ampere is the current through the inductor, and remember, inductor does not allow sudden change of current. Okay. Then after that, this is the exactly at t0 negative. So in a previous class already I have given, this is the t equal to 0. Just before that it is called 0 negative. The switch was open for long time, means it is coming from minus infinite, we can assume. So exactly at this point circuit reached to what? Steady state. Circuit reached to what? Steady state. Then this is called initial condition, t equal to 0 plus. And again the circuit will reach to steady state at t equal to what? Infinite. This is called steady state. And what about this point? This is called initial condition. Initial condition. First of all, at steady state we are finding the current through the inductor. Inductor does not allow sudden change of current, just the switch will close, but current through the inductor will remain same, that is the 5 ampere. And then we can find the equation here. What is the asked here? The current at t equal to 0.5 second. Okay, first of all we have to find the equation. Now the switch is closed. Okay, when the switch is closed, current does not allow sudden change of current. So this is the current. This is the current through the inductor, and that is the current through this branch. Okay. Now, if it is a short circuit path, the inductor current will flow like this. And what about this current 10 ampere? 10 ampere current will flow like this because it will short circuit. It will short circuit the 5 ohm. So what is the current in this branch? 0. So this current will remain constant. But what about the inductor current? Inductor current will finally become 0. So then what is the current through the short circuit path? 10 plus 10 minus, because it is opposite direction. 10 minus ILT. 10 minus ILT. ILT is the current through the inductor. Now watch this. What is the time constant? L by R. So it will become 2.5 divided by 5, that is the 1 by 2 second. Because 2.5 Henry upon 5, that is become 1 by 2 second, that is the time constant. What is the initial current through the inductor? Already we have calculated 5. What is the final current through the inductor? It will be 0, because finally the inductor will discharge through this path, through this resistor. So what is the IL? Equation will become I final minus I final minus I initial e raised to power minus t by 1 by 2, because time constant is 1 by 2. It will become 5 e raised to power minus 2t. 5 e raised to power minus 2t. So what is the complete equation? 10 minus 5 e raised to power minus 2t. That is the equation here. This is the equation. Okay. Once you have the equation, then you can find the value at t equal to what? 0.5 second. 0.5 second, what is the value? You have the equation t equal to 0.5 second. Put the value here, I is equal to 10 minus 5 e raised to power minus 1. Because 2 into 0.5 will become what? 5 e raised to power minus 1. That is 10 minus 5 by e, or what is the e raised to power minus 1? 0.368. Use your calculator and then you can find the exact value of what? I at t equal to 0.5 second. And remember, this is the 0.368. Okay. So that is the answer about, and this is the how to solve the questions on inductor, guys. So in again, I am giving you the one more question we are going to solve here. This is the, I have given the assignment for this. What is the answer for this one? Nandita, Surjit, Shweta, you have solved this question? Yesterday I have given the assignment. Okay, tell me. So already I have solved the 2 questions. Now the third one. Find IT in the figure. Where is the IT? There is the current through the inductor. For t greater than 0. Assume that the switch has been closed for long time. This switch is closed for long time, and exactly for t greater than 0 the switch is opened. Switch is opened. There are 2 diagrams. Always start with, this is a first order circuit. Then IT is equal to I final minus I final minus I initial e raised to power minus t by tau. That is the equation. Okay. Then Shweta, 8.16 you are getting. Okay. Now that question is clear. How to solve the question? Okay then. Now remember, for long time to find this equation we have to find the three things: initial current, final current and time constant. For T0 negative, circuit is in steady state and the switch was closed for long time. When the switch was closed for long time, it will short circuit the 3 ohm resistor, and finally at T equal to 0 negative, this inductor will act as short circuit under steady state. What will be the diagram? This is the 10. This resistor is already short circuited. This is the 2 ohm. This is already short circuited. This is the 2 ohm. This is the 10 volt. So 10 divided by 2. What will be the current here? 5 ampere. What will be the current here? 5 ampere. 10 divided by 2. So that is called initial current, because inductor does not allow sudden change of current. 5 ampere is the initial current. Okay. Then next thing, what is the time constant? Now always remember, when you want to find the time constant of the circuit, then you have to find the time constant for t greater than 0. For t greater than 0, switch is open, remove the switch, and the switch is open, remove the switch. Switch is removed. When this switch is removed, what is the value of the R here? R will become 2 plus 3, 5 ohm. L is 1 by 3 Henry. So what is the time constant? L by R. 1 by 3 upon 5, that is 1 by 15 seconds. This is 1 by 3 and this is 5. So 1 by 3 upon 5, that is 1 by 15 second. That is the time constant. Now two things. Tau is known. Initial value is known. What is the final value? The final value means finally at t equal to infinite. This is the diagram for t greater than 0. Now at t equal to infinite, with the switch open, circuit will reach to steady state, and again inductor acts as what? Short circuit. At t equal to infinite, steady state, inductor acts as short circuit. If the inductor acts as short circuit, then this is plus minus 10. This is 5 ohm. Inductor acts as short circuit. What is the final current? 10 divided by 5, that is the 2 ampere. So final current is 2 ampere and initial current is what? 5 ampere. So what will be the equation then? Okay. Then you can use this equation. IT will become final current 2 minus final current 2 minus initial current is 5 e raised to power minus t by 1 by 15. So it will become 2 plus 3 e raised to power minus 15t. And that is the equation. That is the equation. Very easy. And that is applicable for t greater than or equal to 0. Yes, you have given the right answer for this question. 2 plus 3 e raised to power minus 15t. Now, how we can plot it? How we can? So, what is a very simple question? Final value, initial value, and then you can use. So, normally in GATE, again, you can solve the previous year question. Right? Number of questions are based on same concept. Final value, initial value, time constant. Okay. Then, plot this equation. 2 plus 3 e raised to power minus 15t, that is the equation. Okay. Sometimes they will give you the diagram. Which diagram is correct? So what is the initial current? 5. What is the final current? 2. Okay. This is 5. This is 2. This is the initial current. So always plot like this. This is the initial current 5. Exactly at 40. This is the time. This is constant. For 0 negative it is 5. Now it is start decreasing exponentially. And finally, this at t equal to infinite, this transient term will become 0 and the current will reach to what? 2. And that is the graph. And right here IT. This is the current through the inductor. So this type of curve you will get. Okay, and that is the output. So hope so you got the idea with these 3 questions. So guys, remember, in this series I have completed what? RC circuit. First order RC circuit with source, without source. First order RL circuit with source, without source. And I have given the idea about the capacitor and nature of the inductor. To watch all my session, and if you want more, then please give me the comments and simply subscribe our channel. Okay then. Thank you very much. Now, you are on BYJU'S exam prep, the most comprehensive app for all competitive exams. Like the session, subscribe our channel and share the link of this session. Thank you and good night.